All right, so yesterday we talked about really, really important stuff. We talked about the unit circle, and this is where all of your trig is going to move, and we're going to be able to talk about angles that are greater than 90 degrees, equal to 90 degrees, that kind of stuff, which we have not been able to talk about, and that's what we started with yesterday. Today should be pretty easy if you understand the concepts from yesterday. So the key concepts: you're sitting on a unit circle, your radius is 1. You have points on this unit circle, so it has an x comma y. And we figured out what all those were for basic angles. Some nice angles are 30-degree angles, reference angles are 60-degree reference angles, and our 45-degree reference angles. We'll let the calculator do everything else. And we figured out for our 90s, our quadrantals, that kind of thing. So we also figured out that the y value of those points is our sine, and that the cosine is the x value of those points. So that was our big aha connection. All right, so we're taking that idea today, and all we want to look at in exercise 1 is for each quadrant below, determine if the sine and cosine of an angle of terminal ray is positive or whether it's negative. So what do we have to know about this? We have to realize, like yesterday, that sine of theta is actually our y value. You can remember that because s comes after c in the alphabet, x comes after, y comes after x. So cosine theta is really the x value of our point sitting on the unit circle. All right, well, if we understand that and we know our quadrants, this should be pretty easy. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, so we're looking for in quadrant 1, so I'm over here, if I plot a point, well, what do I know? I go to the right and I go up to get into quadrant 1. So my x values, since I'm going to the right, are always going to be positive. And my y values, since I'm going up, are always going to be positive. So sine is always going to be positive in quadrant 1, and cosine is always going to be positive in quadrant 1. In quadrant 2, what happens? When I plot a point in quadrant 2, I go left first, so my x value has to be negative, left representing negative, and then I go up to get myself into quadrant 2. So left and up gets me into quadrant 2, up being my y value. So sine is positive in quadrant 1, quadrant 2, cosine is positive in 1, but negative in 2. When I go to quadrant 3 and I want to plot a point, in that quadrant I would be going left and I'd be going down. So both my x and my y would be negative. So negative, negative. So as long as you understand that cosine is x and sine is y, it should be easy for us to figure out whether they're positive or negative in what quadrant. So quadrant 4, I'd be going right and I'd be going down, which means my x value is positive and my y value is negative. So sine is going to be positive in quadrant 1, quadrant 2, negative in 3 and 4, because that's where y is negative. Cosine is positive in 1 and 4, because that's where your x's are positive, right? Everything over here. And negative in 2 or 3 when you're going to the left. Okay, so that being said, this should also be easy. Decide the quadrant where the angle is located and whether the trig function would be positive or negative. And then you can check them in your calculator, which we'll just check a couple. So sine of 57. So first, you're forgetting about sine and you're just looking at 57 degrees. And 57 degrees is in quadrant 1. Okay, so to answer the question, we're sitting in quadrant 1. And if I want to know whether sine is positive or negative, I'm thinking y value for the point, right, on the unit circle. So then it's quadrant 1, and therefore my y value in quadrant 1 would be positive. So quadrant 1 and positive. 117, now I'm talking 117. 117 is in quadrant 2, between 90 and 180. And cosine is my x value. So in quadrant 2, if my x value, that means we're moving left, that means it would be negative. Now, negative 87, that means I am starting on the x-axis and I'm going backwards. And I'm not quite reaching 90, but I'm getting very close. So there I am, negative 87 degrees. You should have the visual of that. That means I'm sitting in quadrant 4. And this is a y value, so these are things I'm thinking about. That's a y value. In quadrant 4, I'd be going down as a y value, so negative. 105. 105 is in quadrant 2 again. Okay, so quadrant 2, and I'm dealing with a y value. So quadrant 2 and a y value, that gets me a positive. 257, quadrant 3. Y value in quadrant 3, actually x or y in quadrant 3, both negative. So the sign of 257 would be negative. All right, how about pi over 6? Okay, pi over 6, picture splitting it up into 6, pi into 6. Here's pi over here, here's 0. So taking this and splitting it up into 6, or 3 pieces over here, that would be 4. 3 pieces over there, and 3 pieces over here, and I only want one of them, right there. So I'm sitting in quadrant 1, right? I'm right there, which means cosine x value is positive. All right, negative 2 pi over 3. Okay, so in order to get to pi, I would have to be negative 3 pi over 3, right? Whatever's on the bottom, I need on the top. But I'm only going 2 of them, so that means I'm only going 2 around. So negative 2 pi over 3. So that tells me that I'm in quadrant 3. And therefore I'm negative value. 460, what does 460 say? It says I'm going all the way around. So if I take 460 and get rid of 360, that would be coterminal with 100. In other words, it would end in the same place as 100 does. And I know 100 pretty easily. That's quadrant 2. And it's my y value, so it's going to be positive. 3 pi over 4. Well, 4 pi over 4 would equal pi, right? So 4 pi over 4 would get me all the way to here, but I got to back up a little bit and stop right there at 3 pi over 4. So I'm saying I'm in quadrant 2, and therefore I am positive, because I am the y value. Negative 157. Okay, so negative 180 would get me halfway around, so negative 157 past past negative 90, that puts me in quadrant 3, and therefore my x value is negative. So you're thinking about the angle by itself to figure out what quadrant you're in, and then you're thinking about whether you're talking about the x value or the y value to figure out whether it's positive or negative. All right, so how else can I ask you this question in different ways? Name the quadrant in which the angle theta could fall. So if you know that cosine of this angle is greater than 0, okay, what does that mean for you? That means that cosine of theta is greater than 0, same thing as positive. Okay, and you know cosine is your x value, right, on the unit circle.
The fire drill is complete. Please return to the building.
Positive x value, all right, so cosine x value positive. So therefore, sorry, the fire drill threw me off. Hang on one second. Okay, so cosine of x value, and it's positive. So that means that I am either in quadrant 1 or quadrant 4. In other words, I need to figure out what quadrants would move me to the right for my x value. Here, what it's saying is that sine of theta is less than 0, so it's negative. Okay, same thing as saying negative, and I know that sine theta is my y value, so then I'm asking myself, okay, where is my y value negative? My y value would be negative in quadrant 3 or 4, and this is an and, so they want both to happen. Okay, where do both happen? In quadrant 4. So final answer, quadrant 4 meets both of these requirements. All right, let's try one more of these. So again, this is saying, I know you're greater than, less than. Sine theta is greater than 0. That means sine theta is positive. This is saying cosine theta is greater than 0. So that means cosine theta is positive. And I know sine, we're talking y value. So where my y values are positive, okay, well my y values, that's going up, would be 1 and 2. And here we're saying x values are positive. So then if my x values are positive, we're talking right, I have to be going right, so 1 or 4. And I want one that works for both, so that would be quadrant 1. All right. Using the unit circle diagram, write each of the following as an equivalent trig function with a positive angle and determine the following values. Okay, so we actually want to calculate what this is. All right, so we need to draw a picture. So here we are, 300. Okay, so 300, quadrant 4, there's my angle. Got to draw pictures. So this is theta equals 300. And like we did yesterday, in order for us, we'll picture this is on the unit circle, in order for us to figure out sine and cosine, the actual coordinates of this point, I need to figure out what this reference angle is. So this is a nice reference angle of 60, right? And in a 30, 60, 90, when you are on the unit circle, so the hypotenuse is 1, that was our special situation, then opposite the 60, you got to memorize this, is going to be radical 3 over 2. But I'm going down, so I need a little negative there. Okay? And my x value, which would be opposite the 30, would be 1/2, and I'm going to the right, so I'm going to leave it positive. Okay, so then coordinates of that point on the unit circle would be 1/2, comma, negative radical 3 over 2. That's the coordinates. But they're not asking for the coordinates. They're asking just for the sine of 300. So sine is the y value, so that's my y value. So the sine of 300 is equal to negative radical 3 over 2. All right, so we've got the answer. Now they're asking us one other thing here. Write an equivalent trig function. Okay, so really we're going to analyze what we did here. The first thing we did, we decided radical 3 over 2, not because of the 300, but because of the 60, right? And you decided to use the y, right? The 60 is what made us put the 1/2 and the radical 3 over 2. We decided to take the y value because of the sine. So you can find sine of 300 just by doing the sine of 60, which that would give me my radical 3 over 2. But I have to make an adjustment because down, I'm going down in this case, so I know it's going to be negative, so I know this answer is supposed to be negative. This, however, would not be negative by itself, so I have to put a little negative out in front. So when they say they want an equivalent trig function, this is the equivalent trig function. They both give you the same answer. This and this give you the same answer. Alright, that was kind of tricky, so let's try another one. You got sine of 240, so first thing you should do is draw your picture. You're actually trying to find the value. So you want 240, right? So I'm kind of close to 270 here. 240. Since I'm actually trying to find sine, I need to drop my triangle, form my triangle, figure out my reference angle is. My theta reference would be equal to 60 degrees in this case. Okay, so I got my 60 degrees. And so opposite the 60 degrees, is radical 3 over 2 when the hypotenuse is 1. It's going to be negative, I'm going in that direction. Opposite the 30 is 1/2, that would also be negative. So that means the coordinate of this point would be negative 1/2, comma, negative radical 3 over 2. Alright, but they are just looking for the sine of 240. Okay, so again, I know that the sine of 240 is my y value, so negative radical 3 over 2. And so to write it as an equivalent trig function, this one actually ends up being the same idea. So sine of 60 equal negative radical 3 over 2, but I have to make that adjustment and put that negative out in front. Alright, let's try cos 210. Cos 210, I'm sitting here in quadrant 3 again. 210, drop my triangle. This makes this a reference angle of 30. Remember how important these reference angles are. Opposite the 30, when the hypotenuse is 1, opposite the 30 will be 1/2. Going down, negative. Opposite the 60, which would be there, would be radical 3 over 2, which would also be negative. So I can switch my spots. And so I'm looking for cosine. So I know cosine again would be negative radical 3 over 2. Lots of negative radical 3 over 2's. And if I wanted to readjust this, I really use the 30. So the cosine of 30 gives me radical 3 over 2. But since I'm in quadrant 3, I had to adjust and put the negatives. That would give me my trig functions. Alright. All right, we'll do the last one here. All right, 30 degrees, negative 30 degrees. Sitting in quadrant 4. We haven't done one in quadrant 4. That makes your reference, remember reference angles have to be positive, 30 degrees. So there's your 30-degree reference. And your angle is negative 30. So opposite the 30, 1/2. When your hypotenuse is 1. Negative going down. Opposite the 60, radical 3/2, positive. Right? Going to the right. So I'm looking for cosine of this angle. So cosine would just be positive 3/2, your x value. And what would be an equivalent trig function? Well, I used the positive 30. So cosine of positive 30 gave me the correct answer. It gave me radical 3/2, and I want it to stay positive. So this one's going to stay positive. So that would be your equivalent trig function. That gives you the same answer. So it's kind of just thinking about what you're doing. All right, what do we got left here? Time to work on our homework. Okay, last thing we got to cover. We got to cover what is our Pythagorean identity. If you think about it, so if we're sitting on the unit circle, right, this should make sense to you. You're sitting on the unit circle, we got this triangle here, right? And this is x, the distance I move over for x, this is y, and that's 1. So Pythagorean theorem, x squared plus y squared would equal 1 squared because it's a right triangle. But we also know that on the unit circle, when it's equal to 1, that x is cosine of whatever that angle is, we'll call it theta, and y is sine of that angle. So instead of writing x squared plus y squared equals 1, we can do what's called the Pythagorean identity. Cosine theta squared plus sine squared theta equals 1, or more likely you'd see it written like this. But you have to know that those are the same thing. All right, so directions here. You have an angle alpha. Has a terminal ray that falls in quadrant 2. Okay, so we want to draw pictures of these. All right, so I have some angle that's in quadrant 2. Don't tell me what it is, and that is my alpha. In here would be my alpha reference angle. All right, what else did it tell me? If it is known that the sine of alpha is 3/5. Okay, so visually, sine is my y value, so that would be 3/5. Using the Pythagorean identity, okay, so using the Pythagorean identity means I have to do cosine squared theta plus sine squared theta, or the other way around, equals 1. So there's that. Determine the value of cos, oh, except I'm not using theta. All right, not that it really matters, but we'll fix it since they gave me this angle. All right, so we want to find the cosine of that. Okay, so using this thing, this is when we're on the unit circle. All right, so I know that sine theta equals 3/5. Okay, so I'm looking for cosine. So I could rewrite this as cosine whole thing squared, because those are equivalent, plus sine alpha whole thing squared equals 1. And I happen to know that sine is just 3/5, so I could replace this, 3/5 quantity squared equals 1, and this would be cosine alpha whole thing squared, and a plus. All right, so what do I need to do? I need to square this, and then I need to subtract it and bring it over. So cosine thing squared plus, when I square it, put it in my calculator, 3/5 times 3/5, or 3/5 squared, 9/25 equals 1. Subtract 9/25 from 1, so cosine squared, 1 minus 25 would equal 16/25, if you put that in your calculator. And then how do I unsquare something? I square root it. How many answers am I supposed to have when I square root it? 2. So square root it, I got cosine alpha equals plus minus, big giant radicals, 16/25. What's nice about this is really you're just doing top and bottom. So plus or minus square root of 16 over square root of 25 is really what you're doing. They're both perfect squares in this case. So plus or minus 4/5. All right, so I've got 2 answers, plus or minus 4/5. But, final thing I got to ask myself, is it positive or is it negative? Well, what quadrant am I in? They told me I was in Q2. And what do I know about cosine in Q2? Cosine in Q2 is not positive. It's the x value. Okay, x value is negative in quadrant 2. So I'm rejecting, so cos alpha equals 4/5 would get rejected. Reject, because you're in Q2. Final answer, your cosine of alpha is equal to negative 4/5 in this case. Using the Pythagorean identity to do that. All right, last one. You got an angle theta, it's in quadrant 1. And that opposite would also be my reference angle. Okay, cosine of theta is 1/3. That's my x value, so 1/3, and I'm sitting on the unit circle, so 1. Determine the value of sine theta in simplest radical form. And again, we're using the Pythagorean identity here. So I'm actually looking for this value over here. All right, so sine theta, sine squared theta plus cos squared theta equals 1. Really the same thing as sine theta squared plus cos theta squared equals 1. They gave me cosine in this case, so sine theta squared plus 1/3 squared equals 1. Sine theta squared equals, plus 1/9 equals 1. Subtract 1/9 and bring it over, and I know that sine theta squared equals 8/9. So you do that in your calculator. 1 minus 1/9, use your fraction key. Square root again, same thing. Okay, so sine of theta equals plus minus, big giant radical, 8/9. Split it up. Slide it down here. Sine of theta then would equal plus or minus radical 8 over radical 9. Now, radical 8 is not a perfect square, but square root of 9 is. So plus minus radical 8 over 3. They wanted it in the directions, they wanted it in simplest radical form. So simplify radical 8. So last year you did simplifying radical 8. Perfect square that goes into 8, that would be 4. So 4 times 2. I like 4 because it's a perfect square. Square root of 4 is just 2, so that comes out. And then this 2 right here stays underneath. Okay, so almost done. Sine of theta equals plus minus 2 square roots of 2 instead of square root of 8, all over 3. Last step, decide, is it plus or minus? Okay, so they told me to draw in Q1, and I'm dealing with the y value because it's sine. Y value is positive in Q1. So sine of theta equals 2 radical 2 over 3. I like that one. Sine of theta equals negative 2 radical 2 over 3. I reject because I'm supposed to be in Q1. And that can't be in Q1, that can't be my value, so I am done. All right, that's it. You need to work on your homework. Listen, you've got to practice this, so make sure you do it. I will see you tomorrow.